This is number 2 in the free response question set given by the College Board in their AP Precalculus course description. Okay, so let's see what number 2 says. Students who completed a class participated in a year-long study to see how much content from the class they retained over the following year. At the end of the class, students completed an initial test to determine the group's content knowledge. At that time, t is equal to 0, group of students achieved a score of 75 out of 100. For the next 12 months, the group was evaluated at the end of each month to track the retention of the content. After 3 months, the group's score was 70.84. The group score can be modeled by the function r given by this guy, where rt is the score in points for month t, and t is the number of months since the initial test. Use the given data to write 2 equations that can be used to find the values for constants a and b and the expression for r of t. Okay, they give us 2 points already. Over here, when t is 0, r is 75, because r is the score. So they give us r of 0 is 75, and we plug that into our equation. That would be a plus b ln of 0 plus 1. And then they give us r of 3 is 70.84, which is a plus b log of 3 plus 1. Okay, so those are our 2 equations for the first part. All right, find the values for a and b is next. Okay, so the first guy we can simply simplify it to, because log of 1 is 0, so a is equal to 75. And then this one, we can do 70.84 is, we found a is 75, so 75 plus b log of 4. Okay, we solve for b. We need a calculator for that. You should get that b is negative 3.000806, something like that. Okay, I did it beforehand, so I have the value. Okay, so we found our a and b. Use the given data to find the average rate of change of the scores in points per month from t is 0 to t is 3. Express your answer as a decimal approximation. Show the computations that lead to your answer. So average rate of change is very simple. It's just r of 3 minus r of 0 over 3 minus 0. Okay, so we need to use a calculator for that. So it'll be, well, r3, they give us a 70.84 minus r0 is 75 over 3. So putting this in your calculator, you should get minus 1.387. I rounded, okay? And don't forget your units. We probably need our units here. So we are taking the change in the points over change in months, right? So it should be points per month. All right? Interpret the meaning of your answer in the context of the problem. So our units should help there. So it says that the group score decreases by an average of 1.387 points every month. That's the interpretation, as simple as that. Consider the average rates of change of r from t is 3 to t is p months, where p is greater than 3. Are these average rates of change less than or greater than the average rate of change from t is 0 to t is 3, found in part 1? Explain your reasoning. Okay, so this, it might help us to graph how our r looks. So let me do that for us real quick. So the graph looks something like this. Okay, so what's the key point here in this graph? Let me move it here. So since the graph is, there's a glare over there actually from my lights, the graph is decreasing and concave up. That might be important, okay? So let's go back to here. We can first say that r is decreasing and concave up, right? It's decreasing, but it's concave up. Let me even zoom in, right? Decreasing, concave up. Why is that important? Therefore, the average rate of change is increasing as t increases. Okay, you can even think of it as when we start taking differences, the differences will be smaller and smaller, right? And it's a smaller negative number specifically. So since it's a smaller negative number, it's bigger than before here. It's a bigger negative number. Okay, so that's why the average rate of change is increasing as t increases. Okay, so what does the original problem say? So the average rate of change from t is 3 to t is p is greater than the average rate of change from t is 0 to t is 3. Okay? That justifies our answer. And hopefully, once again, let me explain it. This is concave up, but decreasing. So the average rate of change, you can think of it as we take the difference between this point and this point. It's going to be some small negative number, right? Over here, for example, it's steeper. So it's going to be a bigger negative number. This is more negative, basically. This one's more negative, this one not as negative. So not a negative number is bigger. So that's why the average rate of change is increasing as t increases. So therefore, this average rate of change from t is 3 to t is some number p will be greater than this guy. Okay, hopefully that makes sense. Now let's move on to the last part over here. Leaders of the study decide to use the model R to make predictions about the group's score beyond 12 months. For a given year, model R is an appropriate model if the group's predicted score at the end of the year is at least 1 point lower than the group's predicted score at the end of the previous year. Based on this information, for how many years is the model R an appropriate model? Give a reason for your answer. Okay, so we probably want to just brute force start looking at differences. So for example, we can look at difference between R of the first year beyond 12 months. So after the first year, one more year after the first year. So R of 24, that's 24 months for 2 years, right? Minus R of 12. We want the difference to be less than 1. Is that true? Okay, this would be 65.341 minus, I'm plugging things into my calculator right now, minus 67.303. That's equal to 1.96. Oh, sorry, this should be greater in order for it to be a valid model, right? Because it says at least 1 point lower than the group's predicted score at the end of the previous year. So when we take the difference and absolute value it has to be greater than 1, which it is, right? So after 2 years, it's okay. So now what about R of another year? So 36 minus R of 24. Okay, what's that equal to? Plugging into my calculator, this is 64.164 minus 65.341. Okay. This is 1.176, right? Which is greater than 1, so this is good still. Okay, now let's go to the next year, R of 48 minus r of 36, which is equal to, what's r of 38? Sorry, 48. That'll be 63.321 minus 64.164, which is equal to 0.843, which is less than 1. So this fails the test. Okay, so the model is only good for 3 years. Because by the fourth year, the score difference with respect to last year, let me write it like this. Where's my eraser? By the fourth year, the score with respect to the third year is less than 1. As simple as that. Okay, so hopefully that makes sense. So to recap, this says that the model is good when the score at the end of the year is at least 1 point lower than the previous year. Okay, so between years 2 and 1, the difference is 1.96, so it's greater than 1, right? Because it's at least 1 point, right? Over here, it's still greater than 1, so that passes the test. Over here, now it's less than 1, so the model is not good from year 4 and on. So it's only good for 3 years, okay? And that's the reasoning I put over there, okay? Hopefully this made sense, and hopefully this was helpful. It's not too bad, in my opinion. Please like this video if you found it helpful, and please subscribe to the channel also if you haven't already, and you'll also get notified for the next problem when I post it.